In this video, we'll be learning about the trigonometric ratios in a right triangle. So this is our introduction to trigonometry. Trigonometry is the study of the relationships between angles and side lengths of a triangle. In order to use the trigonometric ratios, it's very important to know that we're working with a right triangle. So a triangle that has a right angle in it. Now, the trigonometric ratios relate the sides to an angle in the triangle. So we always have to start with the angle that we're working with. We always have to start by identifying it. So in the example we're going to be working on, we're going to be working in terms of angle A. So that's my reference angle, that's the angle that I've identified. And the first step is to label the sides in terms of the angle. So we'll start with a side that we already know in a right triangle. It's the hypotenuse. Now the hypotenuse is always the longest side, or it's the side across from the 90-degree angle. So this side here is the hypotenuse. So I'm going to label that. So we found the hypotenuse. Now we look at the other sides. The other side we need to find is the side that's opposite the reference angle. This is my reference angle I'm working with. The side that's opposite of it is the side A. It's across from the angle, so that's the opposite. I'm going to label that. And the other side that's left, we call it the adjacent. So another word for adjacent, it means next to. So we're looking for the side that's next to our reference angle. Well, you might say, well, we have two angles that make up the sides that make up the reference angle, but this one we already labeled as the hypotenuse. So this is the side that's left that's also next to or adjacent to the reference angle. Now that we've identified our three sides, I can show you what the trigonometric ratios are. And these are them. So our trigonometric ratios are the following. We have sine of angle A. So sine is the first ratio. Sine of angle A is equal to the opposite over the hypotenuse. So the opposite divided by the hypotenuse. Cosine of angle A, because remember angle A is our reference angle. So cosine of angle A is equal to adjacent over hypotenuse. So adjacent divided by hypotenuse. And tangent of angle A is equal to opposite over adjacent. So opposite over adjacent. Now you might say these are a lot of new words that you had to learn and you might have a little bit of difficulty remembering it. So we have a mnemonic device here to help you remember. So our mnemonic device to remember our trigonometric ratios is SOHCAHTOA. SOHCAHTOA. So if you can remember this word here, then you can remember the trigonometric ratios. So SOH, S-O-S, that means sine of angle A, so this is an abbreviation for sine, is equal to opposite over hypotenuse. And then the CA part, cosine of angle A, or whatever angle we're working with, is adjacent over hypotenuse. And the last one, tan or tangent of angle A, is equal to opposite over adjacent. Before we do any problems using our trigonometric ratios, we're going to just practice identifying the different sides and the angles in our triangle. So remember, to use trigonometric ratios, we need to have a right angle, triangle. So we need to have a 90-degree angle in our triangle. Now, first question, what is the given angle in this triangle? What is going to be our reference angle to be able to determine all the other sides? Well, we're given two angles. We're given the 90-degree angle and we're given the 40-degree angle. But we don't use the 90-degree angle to write our trig ratios. We always have to use another angle. So the given angle in this example is 40 degrees. Now, what side is opposite the 40 degrees? Well, opposite means across from the angle, so that means side B is the opposite. So that's my opposite side. And the answer here, what side is opposite the angle? That's side B. Now, what side is adjacent to the angle? Well, remember we said adjacent means next to. Well, this side is next to the angle, and this side is next to the angle. So how do I know which one is the adjacent? Well, one of these is the hypotenuse, so maybe we should label that one first. The hypotenuse, remember, is the longest side and the side across from the 90-degree angle. So side C is across from the 90-degree angle, so we might as well answer the fourth question right now. Side C is then the hypotenuse. So that leaves side A, which is next to the angle, next to my reference angle, so it's the adjacent. So side A is the adjacent. Now let's look at an example identifying our trigonometric ratios. So I'd like you to write the ratio for sine of angle E. So the first thing we need to do is label our sides. So we're working with angle E, so this is my reference angle. Now I'm going to label all the other sides. So first I'll find the hypotenuse. That's here. It's across from the 90-degree angle. This side here, 12 centimeters, is across from the reference angle, so that makes it the opposite. And that leaves this as the adjacent. So sine of angle E, sine of E is opposite over hypotenuse. So my opposite is 12, and my hypotenuse is 20. And that I can reduce to 3 over 5, because we always have to have our fractions in lowest terms. Then cosine of angle E. Cosine is adjacent over hypotenuse. So the adjacent is 16, the hypotenuse is 20. And that can be reduced to 4 over 5. And then finally tangent. Tangent is opposite over adjacent. My opposite was 12. And my adjacent is 16. So that reduces to 3 over 4. I'd like you to do these examples on your own. Pause the video here, please, and do them yourself. I'll check these in class. Now let's actually solve for missing values using our trigonometric ratios. Here the steps are provided. When you're solving for an unknown, like we're going to solve for side x here in our triangle, first step is to label the sides according to the given angle. So 32 is my given angle. Remember, we don't work with the 90-degree angle. Well, the x side is my opposite. This side is the hypotenuse, and that means this is the adjacent. So now, my step 2, I have to choose the appropriate trig ratio to work with. Well, I need to have the unknown included, and I need to have everything else that I know. I need to include the side, and I need to include the angle. Because remember, our ratio has 3 parts. The sine of an angle equals opposite over hypotenuse. For example, there's 3 parts. So we have an angle, we have a side, and then we need another side. Well, this is the only one we know. So which ratio deals with the angle, the opposite, and the hypotenuse? Well, that's the sine ratio. So I'm going to be doing sine of my 32 degrees equals opposite over hypotenuse. So I'll put in the values. Sine of 32 equals x over 2.4. Now to solve this, step 3, we have to solve by cross multiplying. Remember, this is like over 1. We're going to do 1 times x, that's going to equal x. And 2.4 times sine of 32. Now this you can do in your calculator. I'm sure you've all seen the button that says sine. That's what you're going to be using. The only thing is your calculator needs to be put in a certain mode. And if you recently reset your memory, it won't be in the correct mode. So you're going to go on your calculator, you're going to press the mode button. And then you're given a menu with many selections. You're going to go down to, I think it's the 3rd row, and you're going to pick degree. You make sure it's highlighted and you press enter. So you'll be working in degree mode. Make sure you make that change, otherwise your calculator won't give you the same answer as you should be getting. Once you've put it in degree mode, you're going to solve. So you're going to do 2.4 times sine, press the sine button, 32, and press enter. Go ahead and do that, please. I want to see, you want to double check to make sure you're really getting the correct answer. If you put it in your calculator correctly, you should be getting 1.27. So that's the answer you should be getting. If you're not able to do that on your calculator, please see me in class and I'll help you with that. So the last thing that's missing here for my x is my units. So well, since the problem here was given in centimeters, that means this side will also be in centimeters. We'll do one more example. Now take a look at this example here. My reference angle is this angle that's given here, 35 degrees. Now I label the sides accordingly. Well, my longest side is the x side, so this is the hypotenuse. This one's the opposite, it's across from the angle, and this one is the adjacent. So which ratio can I use here? I have to use the angle, I have to use the x, because I need to find it, and I have to use the side that I know. Well, this is the only one I know. So what ratio deals with the hypotenuse and the adjacent? So think of SOHCAHTOA. We're going to be using the cosine ratio. So cosine of my angle 35 is adjacent over hypotenuse. So I'll put in the values. Cos of 35 equals 21 over x. And we cross multiply. So x times cos 35 equals, well, this is like over 1 times 21. Now to get x by itself, we're going to divide both sides by cosine of 35. So now you'll put this in your calculator, 21 divided by cosine of 35, and you should be getting 25.64. This last example, I'm going to ask you to finish on your own, but I'm going to get you started on it. So here we're asked to solve the triangle. We're asked to solve the triangle GHI. Well, when you're asked to solve a triangle, that means finding all the lengths of sides and all the angles that are missing. So if we look at this triangle, we know the 90-degree angle, we know angle I, or GIH, and we know the side GI. What are we missing? What information do we need to find? Well, you're going to need to find the missing angle. You need to find angle H. And you need to find the two sides that are missing. You're going to need to find side GH, and you're going to need to find side IH. So if it helps you, you might want to call this side X and solve for X, and this side Y. But you don't have to. You can call it GH and IH as well. I'd like you to solve the triangle. So I've written the steps you need to do here. I want you to find angle H. Use what you know about angles inside a triangle. Remember, angles inside a triangle add up to 180 degrees, so you can solve for that. Find this side and find this side. Please come to our next class with this example completed. I want to see that you've at least tried it, and we'll discuss it further in class.